What's good, everybody? In this video, we're going to be talking about the difference of squares. So I'm going to explain to you guys what that is, how to identify, and how to solve problems on the difference of squares. So when you see this formula, a squared minus b squared, number one, there has to be a subtraction sign for us to factor. If it's an addition sign, we cannot break it down anymore. And to break this down, guys, what we're going to do is take the square root of a, right? We're going to put it in two separate parentheses, and then we're going to go back and get the square root of b and put it in the two parentheses as well. And what we have to make sure is that we alternate the sign to solve. So in problem number one, this is how we would solve, right? So we have x squared minus 49. So I write my two parentheses, right? X squared, we know the square root of x squared is just x. So we have x here, and I know the square root of 49 is just 7. So now after I figure that out, all I need to do is put an addition sign and a subtraction sign, and we have solved problem number one. Now problem number two is the same exact thing. Now they just switch the variable to z squared, but z squared, its square root is just z. Square root of 36 is 6. We alternate the signs, minus, positive, doesn't matter the order, long as they are opposite. And this would be the answer. Now, what they try to do in some of these problems is now they go ahead and they give us a coefficient in front of that x squared term. But guys, the rules still apply. It's the same exact process and steps. So let's say we wrote two parentheses up here, right? The square root of 9 is 3. Square root of x squared is x. So we have 3x as that first term. Square root of 16 is 4. And now all we need to do is just alternate our signs like the previous problems. And we're going to switch back to blue just so you guys can see this more. Now, in our fourth example, what they like to do is switch it around and kind of confuse you. But just remember that 1 is a perfect square. 1 times 1 will always give us 1. So when I write my two parentheses out, square root of 25x squared is just 5x. Square root of 1 is just 1. We're going to alternate the signs. And then this is the answer for our fourth example. But in the second half of the video now, we're going to look at problems where the exponent is greater than 2 and we have a leading term in front of z squared, and we have to also take out a greatest common factor where possible. In the second part of this video, guys, we're now looking at the difference of squares that are going to be a little bit more challenging because we have more than one variable and a leading coefficient. But the rules are the same. So we're going to write our two parentheses out, right? We know that the square root of 49 is 7. Square root of x squared is x. And then now the square root of 64 is just 8. And the square root of y squared is just y. So when we approach it like this, guys, it's much easier for us to figure out. And now all we have to do is alternate our signs. And if you want to double check, just distribute and FOIL these two binomials. Now, problem number two, same exact thing, right? 121, we know the square root is going to be 11. X squared is x, so we have 11x so far. 196y squared, we know that 196 square root is going to be 14. Oops, give this a little bit more space. We have 14y here, and then we have 14y in the second parentheses. Now we switch our signs, and this would be correct. Now in our third example, 4p to the second power minus 100r squared. Same exact thing, guys. So we know that square root of 4 is 2. Square root of p squared is p. So we have 2p as the first term. And then square root of 100 is going to be 10. R squared, we know its square root is r. And now we just alternate our signs. But in the last part of this video, what they're going to do now is give us exponents that are higher than 2. So we're talking about an exponent of 4, 6, 8, 10, and so on. So stick around for that part of the video. Last part of the video, guys, if this video has been helpful so far, just smash the like button for us. So we're talking about the difference of squares, but we're gonna have to pull out a greatest common factor. So what do I mean? So when we pull out 5 out of this binomial, we're gonna be left with x squared minus 16. And now from here, this is the difference of squares which we have to factor. So the final answer would be 5 times x plus 4 times x minus 4. So this is what we mean by taking out the GCF, then factoring for difference of squares. Problem number 2, and I think I wrote my variable wrong. I'm sorry, guys. It should be x squared, not k. What we take out at this part is 3x to the second power. Once we do, we're going to have x squared minus 16. So the final answer for this problem would be 3x squared times x plus 4 times x minus 4. Okay? But now let's go over to our next problem here, because something special is going to happen here, and I really want to show you guys. So the first step, right, we know this is the difference of squares, okay? So I write my 2 parentheses, square root of x to the 4th is x squared, and the square root of 16 is 4, right? One is positive, one is negative. Now at this step here, we are not done. Why? Because we have another difference of square with x squared minus 4. So please be careful and aware of these type of problems. So we're going to have x squared plus 4, and we're going to break down x squared minus 4 as x plus 2 times x minus 2. And this would be our final answer for that problem. And you're going to see this a lot, a lot, a lot. All right. Now let's go down to 4x2 squared minus 144. So if I'm not mistaken, let's take out 4. So I take out a 4, we're left with x squared minus, and let me make sure I get this right. All right, 36, I believe it is. All right, so now, same exact thing, guys. We factored out the GCF, and this is the difference of squares. So our final answer would be 4 times x plus 6 times x minus 6 as an answer. And in the very last problem of the day, we have another example where the exponent is higher than 2. But just remember, when we're working with the difference of squares, we are going to divide the exponent always by 2, okay? So this is going to turn into x squared, right? We'll rewrite it again, x squared. And we know the square root is 81, which is 9. So we have positive, negative, or plus or minus. And now again, similar to x to the 4th minus 16, we have another difference of squares right here, x squared minus 9. So I'm going to rewrite this as x squared plus 9, right? Because we cannot factor that anymore. And then x squared minus 9 is going to turn into x plus 3 times x minus 3. So when we're talking about the difference of squares, guys, you're going to see all of these examples. So to identify, you're going to have to be really good with your perfect squares and their square roots, okay? So hopefully this video was helpful for you guys. Smash the like button for us, subscribe to the channel, and thank you for joining us with Algebra 1 with Mr. Peters on our difference of squares videos.